Hello students, good evening and welcome back with another interesting and vital class. Here I am going to discuss for you on over the concept of the topic reflection of light. Okay, here in this class I am going to discuss the important topics and concepts over the derivation of mirror formula and their appropriate along with their appropriate sign convention. So here is me, Makan Sahu for you. Okay. Is going to explain an interesting concept on the topic reflection of light. I hope and you will find interest. Okay, and also you will follow it and you will apply it in solving problem, different kind of problem based on the concept of reflection of light, which is the most vital chapter. Okay, and the problem are the most important for you in different kind of examination you will find. Let's see. So in this class I am going to explain the derivation of mirror formula for the concave mirror or the real image, so which you can enable to develop your knowledge and understanding that how to derive the formula, right? So mirror formula for the concave mirror. Here is the concave mirror, okay, and you already know about the ray diagram, what is concave mirror, and what about the ray diagram, about the nature of the image according to position of the object. Yes, so the mirror formula is that 1 by V plus 1 by U is equal to 1 by F. Okay, and this formula is not only for concave mirror but also for the convex mirror. You will get the same formula, right? Yes, here use the object distance. Yes, use the object distance, and V is the image distance, and F is the focal length. F is the focal length. So mirror formula for both the concave mirror and convex mirror same, right? Which is 1 by V plus 1 by U is equal to 1 by F. So derivation of mirror formula. Here I am going to discuss the derivation of mirror formula here. And what is mirror formula, students? It is a relationship, it is an equation, it is a formula between the focal length between the focal length F of the mirror, distance of the object U, and distance in the image V. So this is an equation, this is a relation. We also call this a mirror formula, okay, which is a relationship between the focal length F and object distance U and the image distance V. Okay, and object distance, image distance, and the focal length are the three parameters. Okay, with the help of which we shall get the mirror formula. So mirror formula is a relationship between the among the three parameters between the among the image distance, object distance, and the focal length, right? Is it clear? Yes. So what is the use of mirror formula, students? And the mirror equation, or we say mirror formula or relation, helps in predicting the image distance, which is V, the object distance, which is U, and the focal length F of the mirror. It means mirror equation helps in predicting the image distance when the object distance and the focal length of the mirror are known, right? We can find out the image distance if the object distance and the focal length are known, right? Understand? Similar manner also, this equation helps in finding the object distance, okay, when the image distance and the focal length are given. Okay, and also we can find out the focal length and if the image distance and the object distance are given. If we given and we given, also we can find out the focal length. Okay, so here is the, before discussing the mirror formula, it is most important that I would like to tell you regarding the sign convention. Okay, what are the sign convention of the different object? Okay, and in case of concave mirror as well as in case of convex mirror. On the basis of the mirror, the sign convention is most important thing which you have to follow while solving problem Okay, sign convention plays a vital role, right? You see the sign convention for mirror formula. Okay, and you see, and here you see student, this is the principal axis. Okay, understand? And this principal axis behaves like x-axis, and all of you know the coordinate axis. Okay, which is x-axis and y-axis. So x-axis, the horizontal line is known as x-axis. X-axis, yes or no? The horizontal line is known as x-axis. Similarly, the principal axis behaves like x-axis. Okay, understand? And another point, here the pole. Another point is pole. You see here the pole. What is pole? All of you know. And pole is the point of intersection of the mirror and the principal axis. It is a point where the mirror intersects the principal axis. Okay, and the pole is taken as origin. The pole is taken as origin. Okay, and another important thing, all the distances, whether the object distance or image distance or focal length or radius of curvature, all are measured from the pole. All are measured from pole. If you find the distance of the object and distance of the image, focal length, radius of curvature, all are calculated from the pole. Okay, measured from the pole. This is another important concept. Okay, so here you see, look at here. Another important point is that the distance to the right of the pole is taken as positive. This is another important point on the sign convention. Another point, the distance to the right of the pole is always taken as positive. Right of the pole, this is the pole or not? This is the pole, and this is the distance to the right of the pole. Yes, taken as what? Positive. Taken as positive, right? And distance taken to the left of the pole taken as what? Negative. You see this direction here, and this is the pole, and this is the distance to the left of the pole. Left of the pole taken as what? Negative, right? Then the distance measured in the direction of the incident ray. Look at here, the distance measured along the direction of the incident ray. The distance measured along the direction, this is the incident ray. Distance measured along the direction of the incident taken as positive. Okay, distance measured in the direction of incident ray is taken as what? Positive, right? And the distance measured opposite to the direction of incident ray, opposite direction of the incident taken as negative. Here you see, this is the opposite to the direction incident taken as negative, right? This is taken as negative. Okay, understand? Then you see here, another point is that the height measured above the principal axis is taken as what? The height measured above the principal axis. Look at this point. Above the principal axis is taken as positive. Okay, and this is the principal axis, and here B is the object, and this is above the principal axis, so it is always taken as positive, right? Similarly, the height measured below the principal axis, the height measured below the principal axis is taken as what? Is taken as negative. And this is below the image formation takes place in case of concave mirror and is inverted, understand? And this is below the principal axis, so it will be treated as what? Negative. So height of the image always taken as negative because it is an inverted image, and the inverted image is always below the principal axis. Is it clear? And this is the principal axis, and this is the below principal axis image, right? These are the sign convention. So you see here the sign convention for the concave mirror, yes, and here the distance to the negative of the to the left of the pole is negative, and here the distance to the right of the pole is what? Positive, taken as positive, and this is the principal axis, and this is the pole, and this is the height of the object which is above the principal axis taken as positive, and here the height of the image taken as what? Negative here, right? Understand this point? Okay, understand? Okay, so the sign convention mirror formula. So mirror equation follows certain sign convention that are follows. Let us have a review. So what you will learn about this about the sign convention. Okay, the principal axis of the mirror taken as x-axis always. The pole is taken as origin. All the distances are measured from pole. The distance to the right of the pole taken as positive. The distance taken to the left of the pole is taken as negative. The distance measured in the direction of incident ray taken as positive. The distance measured opposite to the direction of incident is taken as negative, right? The distance measured opposite to the direction of the incident ray taken as negative, right? The height measured above the principal axis taken as positive, and the height measured below the principal axis taken as negative. These are the short description about the sign convention. These are very important points, and you have to apply it while solving the problem based on the concept of reflection of light using the mirror formula. Okay, the sign convention is the most important to you. Okay, so I hope you will follow it, and you see here I am going to explain the second part of the explanation, the mirror formula for the concave mirror for the real image. Here is the concave mirror. All of you know the concave mirror, and all of you know the ray diagram for the concave mirror, and what should the nature of the image according to the position of the object. And you see here, and here the object is placed above the principal axis beyond C. Here the object is held beyond C, and according to the ray diagram of for the concave mirror, you know when the object is held, okay, in front of the concave mirror beyond C, beyond the center of curvature C, where is the image formation takes place? Yes, all of you know. Okay, what is the image? The image is formed between C, center of curvature, and F on focus. Yes or no? You see now? Look at here. You see here, this is the object, and here which is beyond the center of curvature C, and here the image is B dash A dash, which is formed between C and F focus, right? Understand? And you see, and you know the image is real inverted when the object is placed beyond center of curvature C. The image is real inverted, and also the size of the image is smaller than the size of the object. So here is the AB is the object, yes, and another thing you see, a ray of light, okay, from the point A, ray of light from the point A along AM, okay, is made to fall on the mirror at the point M, okay, and this ray of incident ray, a ray of light is made to fall, okay, along AM on the mirror at the point M, okay, and all of you know this, any incident ray is parallel to principal axis. After reflection it passes to the focus. Yes or no? Yes. Once again see. Here you see. You see, this is the incident ray. This is the incident ray. AM is the incident ray, and which is parallel to the principal axis. Okay, and after reflection, the reflected ray, okay, passes through the focus. This is the rule of the reflection for the concave mirror and for the convex mirror also, right? Okay, and now for the concave mirror, it is that any ray parallel to principal axis, after reflection it passes to the focus. Okay, understand? And in case of convex mirror, it appears to come from the focus really. But in case of concave mirror, if any ray parallel to principal axis, after reflection passes to the focus, right? Understand? Here you see a ray of light from the point A, S, is made to fall on the mirror and along AM, and parallel to principal axis, okay, gets reflected from the mirror at the point M and passes to the focus F. Yes or no? Right? And here another ray. You see here another ray. The another ray is AP. Are you looking here? Another AP. Okay. And which is made to, this is another incident ray. Yes. This is another incident ray AP and is made to fall on the mirror at the pole. And you know, okay. And after reflection it passes what? Along P dash. Such that the APB angle is equal to A dash PB angle. Understand? APB angle means which angle? APB angle, right? Which angle? This angle is equal to A dash PB dash, which is this angle. Understand or not? And all of you know this is the angle of incident, this is the angle of incident, and this is the angle of reflection. Okay? Understand? This is the two ray and this. Okay. You see now, the two reflected ray actually meet at the point A dash. The two reflected ray actually meet at the point where? Look at here. Look at here. Here, you see, this is the one of the reflected ray passes to the focus. Another reflected ray from the pole passes through along P A dash, which intersect at the point A dash. So here, so A dash is the two reflected ray actually meet at the point A dash, and image is found at B dash. We have to draw a perpendicular from the point A dash on the principal axis. So here A dash B dash is the what? Image of the object, right? Image of the object. So B A dash A dash, here B dash A dash is the image of the object AB, right? Understand? Is it clear? Yes? Okay. Understand? You see, and here AB is the BA is the object, AB is the object, and A dash B dash is the image. Okay. Understand? Now, and you would find out the mirror formula using the important mathematical concepts of simulative triangle, as it is the ray optics. And you know the ray optics is an study of the optics, and which follows all the geometrical property. All the geometrical properties are followed by the what? Ray optics. Understand? So here we are going to prove the mirror formula using the another important property that is known as the simulative triangle, and which you already know, and in the class 10 mathematics also, and your class 9 also you know. Okay? Understand? And we know that two triangular similar. In the two triangular similar, we have to prove it. Here the two triangular similar according to angle similarity property. One of the angle similarity property is there. Okay? Understand? So we have to prove that, and here the triangle ABC similar to triangle A dash B dash. We have the properties of simulative triangle. We have to use the properties of simulative triangle. Okay, the derivation, we have to derive the formula. Okay, you see here the triangle ABC. Look at here. Triangle ABC is what kind of triangle is? Is right angle triangle, yes or no? Yes or no? Which is, this angle is 9 degree. Another triangle is A dash, B dash and C. And also this angle B dash angle, this angle 9 degree. Okay. And this angle is equal to this angle, which is the vertical opposite angles. So according to angle similarity, the triangle are similar. So triangle ABC similar to triangle what? A dash B dash C. So since the two triangles are similar, so ratio of their corresponding sides are what? Ratio of their corresponding sides are equal. It means AB divided by A dash B dash. Look at here. And CB divided by what? CB dash. Yes. CB divided by CB dash. CB divided by CB dash. Right. So here AB divided by A dash B dash is equal to CB divided by CB dash, and the two triangles are similar, ratio of their corresponding sides are equal. Similar manner, the same process, you see here, same process you see, the triangle, see here, you see here, the triangle ABP, you see here ABP is a triangle also, look at here, yes or no? ABP is a triangle, ABP is a triangle, and triangle A dash B dash P, two triangle is also similar according to angle property, all of you know. Since the triangle ABP similar to triangle A dash B dash P, this is A dash, students, A dash B dash P, this is not comma, this is A dash B dash P. So their corresponding, the ratio of their corresponding sides are equal. So AB divided by A dash B dash must be equal to PB divided by PB dash. So we got the second equation, and this is the first equation, and if you see and both the equation, and you can compare to the right hand side, here CB by CB dash must be equal to PB by PB dash, here CB by CB dash must be equal to PB by, we shall get the third equation, okay, by comparing equation 1 and 2, right? Is it clear? Look at the, once again, pay attention, okay, you see here, once again I have written here what, here you see the CB by CB dash is equal to PB by PB dash, and what is CB, let's see, what is CB, what is CB, and CB here, are you able to see the CB, and CB is the PB minus PC, PB, understand, this is PB total distance minus PC, and PB is the what, object distance, and your object distance is minus U. Why minus U? Because the object is to the left of the pole, minus PC is the what, here PC is the distance of the center of curvature on the pole is PC, which is the radius of curvature, is also negative because it is to the left of the pole, that's why it is minus R. So it is CB is equal to PB minus PC, which is minus U, minus of minus R. So minus U minus minus plus, it will be minus U plus R, right? Similar manner, look at your CB dash, look at your CB dash, CB dash, look at here, look at here, okay, you see now CB dash, CB dash, where is CB dash? Is it clear? Once again, see the diagram, because this is the problem based on diagram, you have to do the diagram properly, right? Yes, see here CB dash, this is CB dash, and here you see this is CB dash, and CB dash is equal to what, PC minus PB dash, PC minus PB dash. So PC is the radius of curvature, which is minus R, minus PB dash, here B dash is the image, position the image, so distance the image from the pole is minus V, and here image distance is negative as per the sign convention, which is very much important, so it is negative because it is left to the pole. I already told you, remember that. If you are mistaking the sign, then whole diagram will be, whole calculation mistake, okay, you cannot get the correct value, okay. So it is minus R, minus of minus B is minus R plus B, so image distance is negative because it is left to the pole. So CB dash is equal to PC minus PB dash is minus R plus B. Understand? Is it clear both the points? Yes. Is it clear? Now let us see here. Another point, let's see. Another point, see. Okay. You see now, and PB, what is PB? What is PB? Here B is the object, location of the object, here PB is the distance of the object, which is minus U. And PB dash, what is PB dash? PB dash is the image distance, okay, from the pole, which is minus B. Already I told you. Yes. Now putting this value in the equation, putting the value in the equation, we shall get PB minus PC divided by PC minus PB dash, which is PB by PB dash, and PB minus PC we got what? Minus U plus R. Look at here, minus U plus R, and here PC minus PB dash is equal to minus R plus B, minus R plus B, and here PB is equal to minus U, and here PB dash is equal to minus B. Yes, understand? So after simplifying, you will get minus U plus R divided by minus R plus B, which is minus divided by minus is cancelled, so it is U plus B, right? So here, and you have to transpose a mathematical process. So here the V will be transposed to the right hand side, and it will be multiplied to the numerator. So B whole into minus U plus R. Similarly, minus R plus B is also transferred to the right hand side, and it will be multiplied with the numerator. U whole into minus R plus B. All of you know, okay, how to transpose the mathematical equation, and you see multiply minus B into U is minus UB plus BR minus UR plus UV. Yes, understand? And you see this is VR, and this minus UR is transposed to the left hand side. We have to take to the left hand side. It will be plus UR, sign will be changed, and here UV here, and this, yes or no? Yes, understand or not? Okay, and here this minus UV will be transferred to the right hand side. It will be plus UV. Okay, so here VR plus UR, because R is the common factor, so we have to take as a common, so it will be R whole into V plus U, R whole into V plus U, R whole into V plus U. Yes, and it is UV plus UV is 2UV, right? And here, and you know, radius of curvature R is the radius of curvature. R is equal to how much? Twice of the focal length. Okay, understand? So in place of R you write 2F, and here 2 will be cancelled. Okay, and F whole into V plus U is equal to UV, right? So once you can see, so after cancellation you will get F whole into V plus U is equal to UV. Yes, so V plus U is equal to UV divided by F. F will be taken to the right hand side, it will be divided. Now you see dividing UV on both sides. So V by UV plus U by UV is equal to 1 by F, because UV will be cancelled. So we shall get the required expression, which is 1 by V plus 1 by U equal to 1 by F. Okay, this is the required derivation, relationship, mirror formula. Okay, relationship and equation, and which is most vital. Okay, for the application to solve the various problem. Okay, based on the concept of reflection of light for the spherical mirror, for the concave mirror as well as for the convex mirror. Yes, so finally we got the derivation of 1 by V plus 1 by U is equal to 1 by F. Understood, right? So I hope you will understand it and will follow it, and with proper sign convention. Sign convention is most important factor. Okay, and the various problem, and you will face such kind of problem will face in your future examination, in vital examination. So you have to remember this mirror formula. Before studying the mirror formula, you should know the mechanism. So this is which is the most important part of the learning aspect. What is the mechanism or the process? So here we derive the mirror formula with a certain process. So process is the most important concept, and which is the mechanism of the learning aspect, right? Okay, understand? Okay, thank you. Okay, all of you. So thank you all of you once again for watching the class. Yes.